Hi, welcome to BarnesBasics, and we're going to work a very simple kinematics speed problem. Speed does not imply a direction. Velocity is a vector quantity, so it does imply direction. So we're not going to report directions with this answer. Here is the problem. A man walks 0.81 kilometers to work in 12.0 minutes. What is his speed in meters per second, in kilometers per hour, and in miles per hour? And some important numbers for us to know are that 1 kilometer is the same thing as 1,000 meters. 1 mile is the same thing as 1,609 meters. And the formula that we're going to be using is speed is equal to distance over time, and the unit for distance is meters and the unit for time is seconds in the calculations that we're going to perform to solve this first part right here. So when we look at the problem, we try to identify the information that we're given. In this one, 0.81 kilometers represents distance. So we're going to put 0.81 km here. And 12.0 minutes is time. And so we have 12.0 minutes. Now, the problem that we right off that we see is that this is in kilometers per minute. And we're not ever asked to find that. We're asked to find meters per second. So the first thing that we're going to try to do is we're going to try to convert these numbers to numbers that will fit into the meters per second equation, and then we'll use the meters per second to find these other two questions that are being asked. So let's start right over here. Let's do that. Let's say that 0.81 kilometers, that's what we are starting with, and we're trying to convert that to meters. So let's put meters over here on the right. And let's say that there are 1,000 meters in 1 kilometer. So if we want to get meters, we put 1,000 on the top and we divide by kilometers, 1 kilometer. That allows kilometers to cancel. That will give us the meters. Time is listed as 12.0 seconds. We know that, it's listed as 12.0 minutes. So we know that there are 60 seconds in 1 minute. And so if we multiply 12.0 times 60, we will get an answer in seconds, which would be perfect. That will give us our first answer. So let's do this with the TI-84 first, and then we will do it with the TI-Nspire second. So hit on for your TI-84 and hit clear. And so we're going to say 0.81 multiplied by 1,000, enter, and I got 810. Got 810 here. And then we're going to measure 12 multiplied by 60, and we get 720. Okay, 0.8 of 1,000, that's a roughly good answer there. 12 times 6, we know that's 72. Add some more zero action to this and we get 720. Okay, those seem like reasonable figures. So we're going to put 810 meters divided by 720 seconds right here. We're going to do that. So in our calculator, let's do 810 divided by 720 and hit enter, and I get 1.125. 1.125 meters over second. That's what I get, 1.125. That's not moving very fast. There's about 3 feet in a meter, 3.28, so that's just kind of taking a big step every second. Let's look at the TI-Nspire for just a minute. Let's click on and let's go home, and then let's, at the bottom left of the main screen, we're going to pick the key that says plus divided by minus plus. And we have already configured this in a previous video for scientific or for kinematics calculations. We're going to click the middle screen and we're going to say 0.81 times 1,000, enter, and I got 810, that is correct. Then we are going to say 12.0 multiplied by 60 and hit enter. I got 720, that's very good. And we can just kind of continue on with the TI-Nspire. 810 divided by 720, enter, and I get 1.125 meters per second. This is all on one tab page in the TI-Nspire. Now, at this point, we could go ahead and write an answer here. Remember that in our original problem, this has two sig figs. These are both whole numbers, and so whole numbers count as significant figures. This one has two sig figs, but this is a trailing zero to the right of a whole number to the right of a decimal. That has three sig figs, but remember we used the lowest amount. So if we went with the lowest amount, we would start with a big number and then go to the right. We would say that the answer in this case would be 1.1 meters per second. I would write down 1.1 meters per second. And I would circle my answer, and I might circle that one as well. That's not a bad idea. So the next thing that we're going to do is we are going to use this number. Actually, we're going to use this number, and we'll convert to significant figures in the very end step so that we don't cut the number too harshly during the problem. We're going to use this number in our equations to go to kilometers per hour and miles per hour. So let's start with both of these. 1.125 meters per second. 1.125 meters per second. And let's kind of try to figure out where we're going. Over here at the far right, we're going to try to find kilometers per hour. And then we're also going to find miles per hour. That's what we're shooting for. So what it ultimately means is that in this conversion factor that we do, we've got to get kilometers on the top, we've got to get time on the bottom, and we've got to get miles on the top and time on the bottom. So let's go to kilometers and miles first. We're going to say that there are 1,000 meters in 1 kilometer. 1,000 meters in 1 kilometer, and we're going to say that there are 1,609 meters in 1 mile. Already we can see how meters are going to cancel, and at this point we have kilometers over seconds and miles over seconds. So now we've got to get to hours. To simplify the next step, instead of going from seconds to minutes and minutes to hours, I'm just going to say that there are 3,600 seconds in 1 hour. 60 minutes times 60 seconds, 3,600. This will allow our seconds to cancel and leaves us with kilometers per hour, which is the correct unit. And we're going to do the same thing here. We're going to say there are 3,600 seconds in 1 hour. And that allows the seconds to cancel, leaves us in miles per hour. So I think we're ready to solve these. So let's go with our TI-84 first again. And let's hit on, and then let's hit clear. That might make it nice to do that. So let's say 1.125 multiplied by 1 multiplied by 3,600. Enter, and I got 4,050. And then we're going to divide by 1,000. Enter. And we could divide by 1 again, but that would be the same. So anyhow, I get 4.05 kilometers per hour. 4.05 kilometers per hour. That's what I'm getting right here. Let's hit clear again. See that I've written this down wrong here. This should be 1.125. Okay, got that fixed. So let's go with I didn't get it right. Clear. 1.125 multiplied by 3,600 and hit enter. I'm just skipping that one because it's going to keep everything the same. Divided by 1609 and hit enter. And I get 2.517 miles per hour. That's what I get. All right, sounds pretty reasonable. I think most people walk about 3 miles an hour, so 2.517 sounds reasonable. Let's do this with our TI-Nspire. So we're going to hit on. And we already have a calculator page up. So we'll just continue on this page here. 1.125 multiplied by 3,600. Enter. And I get 4,050. That's right on top. Excuse me. Divided by 1,000. Hit enter. And I get 4.05. That is correct. Okay, that jives. And then let's try this bottom one. 1.125 multiplied by 3,600. Enter. So I get 4,050 again. Divided by 1,609. Hit enter. And I got 2.51709. I got that. So these agree. Very nice. And so let's put these in two significant figures. We're going to obey the same rules. So if we have 4.0, we're going to say that this 5 rounds a 0 up to a 1. We're going to cut it off. And we're going to say this one is 4.1 kilometers per hour. And we're going to circle that. We're going to circle that. And then let's round this to 2 places, 2.5. And we'll say that this is 2.5 miles per hour. That works pretty nice. We'll circle all that. We've shown all of our work. And I think that this is a very good start for us. Pretty comprehensive, kind of, even though it's a simple problem, some complex calculations here. Good job. Buen trabajo, estudiantes. Bueno.